In the over 20-year history of web work, there have been many major changes and adjustments to how problems are authored based on the new macros that have been developed for web work. We will discuss here the most modern way to author problems, which is to use PGML, which stands for Problem Generation Markup Language. Keep in mind that many problems are written in an older system called PG. PGML is built on PG, so learning PGML will be a good foundation for understanding problems written in PG. We'll immediately jump into a few simple problems so you can quickly learn some fundamental constructions in the creation of a problem. The beginning of every problem file should start with a description of the problem and tagging information. Remember, in Perl, the # is used to make comments, and such comments are not interpreted. So in the beginning, we'll want to create a description of the problem for others to see. Our problem is going to be about testing tolerances. Tagging information should be interpreted because that information will be used outside of this file to search for particular problems. Tagging information begins with 2 $. And some of the tags that you want to put in are date, institution of the problem author, name of the problem author, and keywords. Note the format of the keywords. Each keyword should be in quotes, single quotes. Every document needs to start with document and end with end document. The next part is where you load the macros. These are all Perl files that you will need for every PG problem. These 3 are the basics if you want to write your problems in PGML. To separate this section from the next, I will use a series of $. In this problem, we're going to test a student's understanding of tolerance and show how to code a WebWork problem using tolerances. I'll also exhibit a fundamentally important part of WebWork, which is the ability to set random parameters for your problem. We first tell WebWork what kind of problem this is by setting the context. There are many mathematical contexts that have been created for WebWork, and I'll discuss some of them later. Since this problem deals with numbers, most likely the correct context is numeric. We now use the random function to set a random tolerance and set the lower bound, upper bound, and incremental division of the random number. Now we specify that we will need the tolerance flag set in this context. Flags and set are methods. Tolerance is an attribute, and so is tall type. And here you're setting the tolerance and the tolerance type. Finally, we set a Perl variable equal to the target number. We now write what the student will see. Which are encased with begin PGML and end PGML. We want the student to type in the number plus or minus a tolerance. These are instructions for the student, and note that if I want the variable replaced by the actual number, I need to enclose it in brackets. This escapes me out of the text environment and puts me back into Perl. So that whatever is in brackets will be replaced by the random number that was chosen. The same with the random tolerance. Coding the answer blank for the student is easy. It's just bracket, underscore, underscore for the length that you want to give the student, and then you close again with a bracket. Coding the answer is also easy. We put that in curly brackets after the answer blank. In this case, we just want the student to type in the number, but within the given tolerance. And that's taken care of in our context settings right here. Next, we provide the solution to the problem, which is encased in begin PGML solution and end PGML solution. In the solution, I want to typeset mathematics using LaTeX. To do this, I escape the text environment and enter the LaTeX environment by using this bracket and the backquote symbol. This is located frequently underneath the tilde symbol on a keyboard. So this set of bracket backslash will typeset y in LaTeX. If I want a display style equation, I simply use double backquotes and the brackets. We have now coded in all the important parts of a problem. Now we just save it and test what we have written. That'll open up in a new window, and we will see what the student sees. So now let's test if the problem checking was coded correctly by just solving the problem. Type in 0.3 within a tolerance of 0.07. So, for example, 0.35 should work, and we can just check by showing the correct answers and checking the answers. As expected, since 0.35 is within 0.07 tolerance of 0.3, this is correct. Now why don't we see if 0.39 works? Again, as expected, it is incorrect. And to make sure the tall type, as we had coded, was absolute value, let's check 0.27, which is within tolerance. And as expected, that works. Let's check 0.2, and it doesn't work. So everything looks okay. But now let me show you some common errors. If you forget these brackets, for example, let's see what happens. We're going to update it. You see how now we have literally what we've typed, which is $number and $x. So it's important when you want to display the actual Perl computation within the text boxes that you put all Perl variables in brackets. Let's see what you will get when you remove the LaTeX symbols, for example. Everything looks fine because the error was in the answer. So let's just type in any answer. Check the answer. And the solution does not display LaTeX. This should be less than or equal to. This should be less than or equal to. Let's look at it again with the proper escaping into the LaTeX. Take action, look at the solution, and we'll see that the less than or equal to is rendered correctly. We'll now move on to slightly more complicated problems written in PGML.